Alright guys, today we've got some more exponent rules that we need to learn. All of the ones yesterday were all derived from multiplication. So now we're going to look at some ones that have quotients involved, that have division involved, okay? So here, quotient of two powers with equal bases. This one says if we have x to the a divided by x to the b, we should subtract the exponents. So a specific example, again, would be x to the fifth over x to the second is equal to x to the third. A good kind of way to show this is if we expanded this out and wrote 5x's up here and 2 down here, you would have a bunch of fractions that could be simplified. Okay, you've done some simplifying of fractions before. X over x would cancel, x over x would cancel, and we'd have 3 x's left in our numerator, which is just x to the third. That's really all this rule is saying, is that x's over x's cancel to 1's, and so we take away the ones on the bottom from the ones on the top. That's pretty simple. Okay. The next rule, a power of a quotient rule, is pretty much exactly the same as the power of a product rule. And this rule just says that if we have x over y to the a, we can distribute that exponent to our numerator and denominator. Again, a specific example would be x over y to the second is equal to x to the second over y to the second. Again, this makes sense because in expanded form it would just be x over y times x over y, and we can see that x times x is x squared and y times y is y squared. This rule, now I didn't put this specifically down because we've already done power of a power, but where you see this rule applied a lot is where you have a fraction with some exponents in it and an exponent on the outside. Since you can distribute that exponent to both numerator and denominator, and they have powers in them, you're just going to multiply the powers in this situation. Okay, so like this example would be x to the sixth over y to the ninth from multiplying your exponents. That's where you see it applied a lot. Okay, so again, we've got some very, very, very specific examples down here. These will get a little bit trickier than the last ones because there's just a few more rules we can bring into play all at once. So try A, B, and C, see what you can do on your own, come back, and then let's see how well you did. Okay, hopefully you took advantage of that opportunity to try these on your own. This one should just be x to the sixth. 4 of our x's are going to cancel with 4 of the x's on top, leaving 6 x's. Subtract your exponents. Here we can kind of break this down into 3 different fractions. The number fraction, the x fraction, and the y fraction. 15 over 5 is 3. X to the sixth over x to the second is x to the fourth. And y to the seventh over y to the fourth is y to the third from subtracting our exponents. Hopefully that one was pretty straightforward. One more last example. Now this one was just a little bit tricky. Not too terribly tricky, but just a little bit. Okay, so here we first need to distribute our exponent to the y and to the x. So our first fraction doesn't change at all. And then we've got y to the third over x to the third. Now remember, when you're multiplying fractions, that just means you're multiplying your numerators and multiplying your denominators. And we're allowed to reorder multiplication, so I'm going to reorder it so it's just a little clearer what I'm doing. X to the ninth over x to the third is x to the sixth. And y to the third over y to the third just cancels out completely. It's gone. Okay, you could write y to the 0 if you wanted, but we're going to talk about 0 and negative exponents in our next one. But for right now, you could just cancel that out completely because they're the same thing. And you know when you have the same thing in your numerator and your denominator, the same factor, you're allowed to cancel those out. Okay, that's it for this one. Try some practice problems, see how things go.